Okay, so we've talked about how equations have energy associated with them. All right, we've talked about what delta H means, the change in the enthalpy, which is the change in the heat energy. When it's negative, we know what that means. When it's positive, we know what that means. All right, and to refresh us, if it's negative, for enthalpy, you're thinking about heat, you think of yourself as the object. So if it's negative, that means you're losing heat energy, okay? So you're losing heat energy when it's negative, all right? So that would be exothermic because you're losing that heat energy. If it's positive, the opposite's true. That means you're gaining heat energy, so it's endothermic, all right? So that's kind of the vocab, the thought process of all of what we've been doing in this chapter. Now, the interesting thing with these problems, and I said before that they're kind of like little puzzles, is they tell you what the answer is. So it says find the change in delta H for the conversion of diamond to graphite. So that's the answer. That means they want you to make an equation that looks like C diamond going to C graphite. Now the neat thing about this is we remember, or we might not remember, that carbon has 3 allotropes. So carbon can exist in 3 different forms, and it's just carbon. It can be diamond, it could be graphite. And does anybody remember the third form that it could be? Really odd. It was the buckyball. It was a Buckminster Fullerene, which was just a carbon circular structure. And so with this, we want to make these 2 reactions, these 2, we'll call them half reactions, form this here. So if you take a look, here's the carbon graphite, here's carbon diamond. What we can do is we can flip them, we can double them, we can divide them. Whatever we do, we have to do to all of them. You know, to like A, we would have to, if we double it, we'd have to double the C, we double the O, we double the carbon dioxide, and we double the number as well. Or we can flip it, you know, depending on what we need to do. But the goal again is to get diamond as a reactant and then to get the graphite as a product. All right, and both of them are right now, they're reactants. So out of both of these 2 equations, which one do we need to flip? Because we need to get one of them to be the product. A or B? B, let's check it out. All right, so if we flip B, that's going to take C diamond and put it on the product side. But what we want is we want diamond to be a reactant and we want graphite to be the product. So we're actually going to flip A to get graphite on the product side. Everybody okay with that fundamentally? Like, it makes sense that we need to get it on the other side, so we're going to flip it? This is how we do it. We go, okay, we're going to move this to the product side, which means this is going to be the reactant. So what I would do is I would just lightly cross this out, because you still have to be able to read it, and then I would rewrite it flipped. Anywhere in the margin, real tiny, so you can fit it around there. And then we do C, this is graphite, plus O2. And then the delta H gets flipped also. So instead of it being negative, now it's positive. All right, everybody okay with that? Cool, so we flipped it. I like to align the arrows also, because here's a neat trick. We haven't really spent a lot of time with this. This year, everything on the left wants to be lined up and everything on the right. We want to have all the reactants and the products lined up, because if you have something that's on the reactant side and the product side, they're going to cancel out, all right? So the carbon dioxides are going to cancel out. And does anything else cancel out? Anything else on the reactant and the product side? What's that? Yeah, the O2. It's a reactant here and it's a product here. So what's left over once we do all that crossing out? Diamond and graphite. And remember, that was the answer, right? That was what we were expecting to find before. We wanted to get C diamond yields C graphite. Now, if you're like, well, why did we do this if we knew what the answer was? Well, we want to figure out the delta H, so we want to figure out the numbers. So now, because we flipped this delta H down here, it's plus 393.5 kilojoules, we're going to add that to the negative 395.4 kilojoules, and that will give us the change in it. So we add those two numbers together, and that will give us our answer for this. And what do you get when you do that? Negative 395.5 plus 390, oh, I said that wrong, sorry. Negative 395.4 plus 393.5 gives us negative 1.9. Did you guys get that? Awesome. So delta H equals negative 1.9 kilojoules. So the goal of this is to figure out what the equation is going to look like, all right, which they tell you, but you have to flip it around and make it work that way so that you can then add the delta H's together and come up with a number. Now, if we didn't flip it, we wouldn't get that number, right? We'd get negative 700 and something because we would have just added these two things together. So it's important to figure out these parts and then, add them together. And sometimes you have to double them, sometimes you have to divide them. And again, it's just manipulating the numbers around so you can figure out what the overall energy change is. All right? You guys okay? All right, cool. We're gonna try one more.